here we want to look at what's called the end behavior of a function. So first thing we want to look at is there's only kind of 4 things that can happen, because they're not talking about what happens in between, like the function could be squiggly in the middle. They're just saying in general, after it maybe crosses the x-axis a few times, depending on the degree of the function, who knows what happens, but eventually what happens. So as you make x really big or really small, does the function eventually go towards infinity or negative infinity? So first one is, what if they both go up towards infinity? So as this goes this way, so it rises to the right and rises to the left. They could also both go down, so as x gets smaller, y gets smaller. And so notice this isn't talking about anything could happen in between there, just what's the end behavior, what eventually happens to this function. And then we could have one going right and one going left. Or we could have it rises to the left and falls to the right. Alright, so if we look at some functions that actually do this, it makes it easier to pick up on the pattern. So think of a function we know that maybe goes both up, like a parabola. And so notice something about a parabola is the leading coefficient is positive, which is what makes it open up, and it has an even exponent, so like x squared, x to the 4th, x to the 6th would all do this. And notice this one would be like a parabola that opens down, so it's got to be an even exponent, but it could be negative. And then notice this is kind of like x to the 3rd, and so if it has an odd exponent, it'll do this. If it has a negative leading coefficient and an odd exponent, it will look like this one. So there's really only 4 choices here. And then the good news is when you're looking at your function, all you care about is the leading coefficient. The leading coefficient determines the end behavior. So when you look at this very front number, negative x to the 5th, so it looks like that has an odd exponent and it's negative out front. So it's going to have the same behavior as this one, which is it rises to the left or goes to infinity as x goes towards negative infinity. So it goes off towards infinity to the left, and then it goes towards negative infinity down forever to the right. And so then just pick the correct answer choice that goes along with that. Alright, so once you pick up on that pattern, then you can do any of the rest of them pretty quick. Like, let's look at another function. So once again, we only have to look at our leading term. So our very first one here has a negative coefficient and an even exponent. So which one has a negative coefficient and an even exponent? So it looks like this is going to be a falls to the left and a falls to the right. So it goes towards negative infinity on either side eventually. Alright, what if they have one, maybe they give you a function that's not already multiplied out? Do you technically have to multiply the entire thing out? It couldn't hurt, but you can get away with just looking at, okay, what would my first term look like? So notice when I squared this, if I FOIL it, right, I'll get a few terms, but my very first term in there is going to be an x squared, so x squared plus ... So now notice my first term, when I multiply by this, x times x squared will give me x to the 3rd. So I multiply those two together, it's going to look like x third plus a bunch of stuff. So if you want to, you can be a little lazy about the rest of the terms, since for end behavior all I care about is the leading term. So now when I multiply this 2x in here, looks like my leading term is going to be 2x to the 4th plus, there'll be a whole rest of the polynomial there, but we only need to look at this term anyways. And even from back here you could say x squared times x times 2x, so 2x to the 4th. So it's positive and an even exponent, so it looks like it's going to follow the same behavior as this one, which is rises to the left and rises to the right.